These are the 1.5B notes. Today we're going to be talking about inverses. So inverses is just the mapping backwards. So instead of having an ordered pair like x, y, the inverse is going to be the ordered pair y, x. So you're just flip-flopping those. So if it gives you a list of points, you're just going to flip them around. So 2, 5 becomes 5, 2. 3, 8 becomes 8, 3. 4, 11 becomes 11, 4. And 5, 14 becomes 14, 5. So you switch the x and the y. You don't change any of the signs, though. Notice I didn't change any of the signs. So that's pretty basic there if you want to try to make your curly bracket around the outsides. And then we're going to do this same thing, but with the equation. So in order to do this, we're going to first start by switching x and y. So on example number 2, you would literally make the x into a y and the y into an x. Don't move anything else, though. And then at the end, you have to make sure that you solve for y. You want your answer to be y equals. So for example 2, we'll subtract 3 from both sides and divide by 2. I'm going to bring my y equals in front. And then you can write that as x over 2 or even as 1/2 x minus 3 over 2. A lot of different acceptable ways to write that. I'm going to write it like this because that's how it looks more in a slope-intercept form. All right, example number 3, when you see f of x, you want to change this to y. F of x is equal to y, so this would be y equals, and then you can switch your x with your y. And from there, solve for y. Let's write a little note up here. Change to y. All right, I'll add 9. So x plus 9 equals y squared. Then you want to get the y by itself, so by getting rid of the square, you would need to square root. Again, I'll bring the y in front. I just think it looks better as an answer. And you have the square root of x plus 9. For example number 4, it says find f of -1. F to the -1 is just the shortcut way of saying inverse. So that's the little symbol that they came up with for inverse. It has nothing to do with negative and nothing to do with a 1. It's a really terrible symbol, but that's what they chose. So our example really just says find the inverse if f of x equals 2 over x plus 3. We'll start by changing the f of x into the letter y. And then we'll switch our x with our y. And then I'm going to go ahead and put this x over 1, and I'm going to cross multiply. So I'll get x times y plus 3, and I'll set that equal to 2. Then from here, maybe we distribute. Xy plus 3x equals 2. Bring that up over here, continue working. And let's see, I think I will try to get the y by itself. So let's subtract the 3x to the other side. Then we'll divide by the x. And this problem's a little strange looking. So I'm just going to go ahead and divide it by x like that and then leave the whole thing alone. 2 minus 3x over x. There we go. All right, so what do functions or inverse of functions actually do? They literally take you back to where you started. So if we go back up to the top, 2 took you to 5. This kind of takes you back. 5 takes you back to 2. So it gets you back to the number that you started. It reverses what we've done. So in order to show that two things are inverses, we're just going to choose any two numbers and show that it actually does reverse it. There's kind of a little explanation. It takes you back to the number you started with. So these two things are inverses. So what we'll need to do is pick any number. Now you can choose any number as long as it's a number that's easy for you to work with. So I wouldn't choose -72 or a decimal or a fraction. I would just go ahead and choose a regular old number. Let's say we choose 5. Choose any number, right? So let's just say I picked 5. So I'm going to start by plugging a 5 into my problem right here. And I get 14. So when I plugged in a 5, I got an answer of 14. Now, what we have to do to prove that it's an inverse is plug it into this other equation, but we're going to start with a 14 and make sure it maps us back to the 5. So 1/2 times the 14 minus 2, which is 7, minus 2, which is 5. So when we plugged in a 14, we got an answer of 5. And you can see that those are inverses. 5 went to 14, 14 went back to 5. This should work with any number that we choose to do. Let's try a different number. Let's try maybe a negative. So 2 times -1. Let's try -1. It's -2 plus 4. That's 2. So -1 took me to 2. Now the goal is to show that 2 is going to take me back to the -1. So half of 2 is 1. 1 minus 2 is -1. So when I plugged in a 2, I got an answer of -1. You can see it does take me back to where I started. All right. For the next part, we're going to do some graphs here. When we graph the inverse, we're just going to switch the x's and y's and then plot the new points. It will always end up being a reflection over this y equals x line, that diagonal line down the center. So 6, 8 becomes 8, 6. And if you want, you can make a little list up here of the ordered pairs if you want, or you can just directly start plotting 8, 6. You can write the ordered pair next to the dot if you want. You don't have to. 1, 4 becomes 4, 1. There. -2, 3 becomes 3, -2. -4, -1 becomes -1, -4. And -5, -4 becomes -4, -5. Again, you can see it looks like all the points are just diagonal across that y equals x line. We didn't change any of the signs. All the signs stayed the same. All we did was flip the location of the x and the y. And then because those dots were connected, I'll connect those as well. Probably going to need this 8, 6 up there. Take that out. All right. For example number 7, they were not nice enough to list any of our ordered pairs for us, so we'll have to list the ordered pair and then switch it around. So I'm going to start over here on the right with this point. That point looks like it's 3, 2, 3, 4, 5, 3, 6. So that's going to need to get inversed over to 6, 3. Next point is 2, 1. Have to get inversed over to 1, 2. 1, -2 is going to have to go to -2, 1. And I write this out because as I'm doing it, I tend to forget some negatives and things. So if you want to go directly and put the inverses onto your graph, that's fine. 0, -3 becomes -3, 0. -1, -2 becomes -2, -1. It's that point. And -2, 1 becomes 1, -2. That's that point. And -3, 6 becomes 6, -3. All right, I think I got all the points. Now I'm just going to reverse them. I'm going to plot my inverses. So let me switch a different color or something. There we go, purple. So 6, 3, right there. 1, 2. -2, 1. That's a dot on top of another dot that's already there. That's okay. It does not mean you're wrong. -3, 0. -2, -1. 1, -2, another dot on top of another dot, and 6, -3 would put you right there. So notice it looks like the parabola got tipped over on its side. The only mistake I ever see students make on this, first of all, forgetting a negative. Secondly, anticipating or guessing what the graph is going to look like before they plot all the points. So once you get a couple points, resist the urge to just finish off the parabola, do all the points to make sure you have it located in the right place in the right direction. All right. Example 8, very similar. This is what it looks like on delta math. So delta math requires you to do 5 points. So you don't have to do every point, just pick 5 of them. I would say that the easiest points to pick would be your vertex, the 2 on each side, and then the next point that it happens to cross. Those are the ones that I would do. Those are the ones I would recommend. So -9, 4 becomes 4, -9. -8, 5 becomes 5, -8. I'm going to do these in a slightly different order than I did the one up above. But any order is going to be fine as long as you have all the points. -5, 6 becomes 6, -5. And -5, 2 becomes 2, -5. If you start off with a parabola, your answer should also be a parabola. You're not going to go from an inverse parabola and then draw a line all of a sudden. All right, let's switch colors. 4, -9. 5, -8. 3, -8. 6, -5. And 2, -5. Looks just like that. All right, there you go.